Hello, this is video number 6, the Moving Man video. In this video, I like to use this applet here, which you can download for free from this website here, and you can play with it too. And I like to use it to give a quick introduction about some of the kinematic quantities that we're going to be using in this course and in the following videos. So the first quantity here is position. So this one just tells you where you are. So if I give it a position of 2 meters, then the man is now 2 meters to the right of this 0 meter mark. And if I give him a position of negative 2 meters, then he is now 2 meters to the left of the 0 meter mark. So the position just says where you are. And what is noteworthy here is the use of the positive and negative sign. So a negative sign usually implies motion to the left, and a positive sign motion to the right. The next thing I would like to go over is velocity. So let's go ahead and reset this. There's a reset button right here. And let's give him a velocity of 1 meter per second. And let's not give any acceleration. So you can think about what you think is going to happen. And let's take a look. So he moves to the right. And he moves at 1 meter per second. So if I stop him when he gets to 6 meters approximately, I stopped him a little bit short, but you can see 6 meters would have taken him 6 seconds because 1 meter per second means he travels 1 meters every second. And so you can imagine that if instead I gave him a velocity of 6 meters per second, you can think about how long it would take to get to the 6 meter mark. And hopefully you said 1 second, because now he travels 6 meters every second. So that's just a little bit about velocity. And also what we can do, I'm going to reset again, is give him a negative velocity. Let's see, -1. And you can imagine this is similar to the position, and a negative is going to imply here that he's going to move to the left. So you can see, I like this applet, you get a good visual that negative velocity, you are moving to the left. And then the last thing I'd like to discuss is a little bit about acceleration. So I gave myself a few notes here to remember what to try here. So let's try velocity is 1 meter per second and acceleration is 3 meters per second squared. So when you think about acceleration, you're probably thinking about speeding up, right? You think about in your car, you press on the gas pedal and you speed up. So let's give him a positive acceleration. So 3 meters per second squared actually means that every second he's going to speed up by 3 meters per second. So when he gets to the 6 meter mark, it's going to take him less than 6 seconds because he's speeding up. Let's take a look here. And I was a little bit late shutting him off, but it takes about 1.7 seconds to get to the 6 meter mark because now he doesn't have a constant velocity, he's actually speeding up. So in this case, a velocity that was positive and an acceleration that was positive to the right meant that he was speeding up. But now let's take a look and see, well, what about a negative acceleration? Most people think that that means that you're going to be slowing down, but this is really important. A negative acceleration does not necessarily mean that you're slowing down. So my next example is to give a velocity of -1 and an acceleration of -3. So you might think, oh, well, negative acceleration, he's going to slow down, but look and see what happens. I'm going to hit play, and I'll stop it when he gets to the -6 meter mark. So you can see, again, it took about 1.7 seconds to get there. That means he started at -1, which just means that he was moving to the left, and it definitely took him less than 6 seconds to get to the 6 meter mark, the -6 meter mark, because he was speeding up. So I really like to have this visual example to show you that a negative acceleration does not necessarily mean that you are slowing down. In this case, your velocity was to the left, your acceleration was negative, and both of these cases meant that you sped up. So let's take a look and see an example where you actually are slowing down. So the last example I wanted to show here is start with a velocity of 3 meters per second and then give an acceleration of -1. And now let's see what happens. So he's initially moving pretty quickly, and then look, he slowed down. And I just stopped it so I could pause it for a second, but look, he slowed down. I'm gonna keep it going now. Look, he stops, and now he turned around. And now if I keep playing, let's see, with that negative acceleration, do you think he's going to be speeding up or slowing down? Well, we saw in the previous example that if he was already moving to the left, a negative acceleration would mean that he would actually start speeding up. And you can see, hopefully, in this animation that he does indeed speed up as soon as he starts moving to the left. So what's really a good visual with this applet here is that you see that when the velocity was to the right, but the acceleration was to the left, that he slowed down. And he actually stopped. And then it went back to this scenario here that he was going to the left, and then he started speeding up. So as you can imagine, if I had him going to the left instead, and now had given him a positive acceleration, that would also mean that he's slowing down. Whenever the velocity and acceleration are in opposite directions, that means you're slowing down. I'll demonstrate it. So reset here, give a velocity of -3 meters per second and a positive acceleration, and look what's going to happen. He slows down, stops, and then starts moving in the opposite direction. The last thing I want you to pay attention to, because this usually pops up somewhere in some questions, is the fact that the whole time he was moving here, there was some acceleration. And even though there was some acceleration, it was possible for the moving man to be stopped at one instant. At the moment that he's turning around, just a change in direction, there is some acceleration, but the velocity is 0 because he stopped for that particular instant. So hopefully this was a quick little introduction to some of the kinematic quantities that we're going to see. And now if you look at the next videos that I have, then you keep this visual in mind, and hopefully these next videos will be easier to understand.